Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have more than 14 years of work experience in the fields of artificial intelligence, software development, and robotics. This video is part 2 for Pathfinder AI project. Let's continue. Then comes the DQN model, creating the DQN model. So this is the code for creating the class. So I will tell you step by step what it means. So the DQN model consists of three fully connected layers. It accepts a 2D input, that's agents x and y position, and outputs q values for the four possible actions. So what are the four actions? Either it can move up, down, left, right, only the four directions. Those are the four possible actions. So the DQN class defines the deep Q network. DQN full form is deep Q network model used in this reinforcement learning setup. The network architecture is simple feed forward neural network. So what is feed forward? Going layer by layer with fully connected layers with RLU activation functions. So I have mentioned the details here. So class definition and initialization part. Using the init method you can initialize the classes. So the constructor method initialize the network layers based on the dimensions of the input and output. Here input underscore dim the number of features in the input, 2 representing the x and y coordinates. Output dim is the number of possible actions, 4 representing up, down, left, right. So these are the possible actions that I think defined in the code also. I will show you. So this is what this class init initialize function or method will take. Layers of the neural network are FC1, FC2, FC3 in the code. I will show you this in the code. I told you this one. Then no, not this one. No, I told you about this one. Then comes this code, this class part. So what this is, and as I told you, state dim is 2, so x and y coordinates, because we are moving on x and y coordinate. Action dim is 4, this means up, down, left, right. So this will be passed here and goes through the layering part of the neural network. So the first fully connected layer takes the input and maps it to 64 neurons. See in this argument 64 neurons. Second layer also with 64 neurons processes the output from the first layer. As you know, now what we are doing is in reinforcement learning, it will remember the previous inputs also, if you remember in reinforcement learning. So from the first layer, the hidden layer allows the model to learn complex pattern in the data. And self.fc3, this means the final layer maps the 64 neurons down to the output dim, which represent the q values for each action. As you know, the output dim. So let's see. Okay, so here is the code. So each value is associated with the potential action that the agent can take. And what action can agent take? Move up, down, left, right. Let's see the forward pass. The forward method defines how the input data moves through each layer. So input is passed through FC1 and activated with ReLU, adding non-linearity to allow the network to learn complex representation. Remember these words, complex representation. Then comes the part, the output from the first layer is processed through FC2 and activated again. How it is doing it, as it is being stored in X, and we can pass this here, so it will be used in next layers also. So the again we are passing X here, so the final layer outputs q values without an activation function, as the q values represent expected rewards for each action. I think I mentioned somewhere in this article. So the positive reward, if it goes on in the correct direction, is 100, for example, and minus 100 is if it goes on this obstacle. And I think I have implemented negative reward. So let's see in this article, but this is the thing. So this is what the reward is if it goes in the correct direction or in the correct way. So you can see I have now the movement of this agent, it is moving perfectly to the final destination, almost perfectly, not going on obstacle. I think it has remembered the previous path. Yeah, see how perfectly it is going. So this is what happens when we use reinforcement learning. Okay, so let's see the initialize DQN component. Initialize two networks, PolicyNet for learning, and target net for stable target values. And as you remember, what target is final output. So set the optimizer, loss function, and experience replay memory. So let's see the code, what it means. Okay, where is this code? This one. So yes, so state and action dimensions, state underscore dim 2. So the state dimension is set to 2 because the agent state is represented by its xy coordinates on the grid. Action dim 4, the action dimension is set to 4, representing the 4 possible actions the agent can take: up, down, left, right. Policy and target network. So policy underscore net DQN state underscore dim action underscore dim. So the policy network is the main model for the agent uses to decide actions based on the current state. It's a DQN model with input and output dimensions set to state dim and action dim, as I told you what state dim and action dim is. So the target underscore net, the target network is a separate copy of the policy network. It is used to provide stable target Q values during the training. And what Q values is, I already told you, it can take only 4 direction or actions, so it can move up, down, left, right. So Q value tables will be created. So this is how the reinforcement learning works. From this table it will know the best possible path it can take to reach the destination. So what this will do is, this copies the weights from policy net to target net, ensuring they initially match. During training, the target network is updated less frequently than the policy network to stabilize learning. So let's see the optimizer and loss function. The Adam optimizer is used to update the weights of the policy network based on the gradients calculated during backpropagation. And if you remember, backpropagation going from bottom to top. So the learning rate controls the step size for each update. Loss function, if you remember MSE, I told you MSE mean squared error many times. So the whatever the error comes, it will be squared. The model will understand if the for the higher values it will make more decisions. So calculate difference between predicted Q values and target Q values. So what it predicted and what should be the final values. It will see the loss, understand the loss. If you remember, I think I have used this in housing project. So helping the agent to minimize the error during training. Let's see this replay memory, experience replay. So what this line means is, this is a DQ, double-ended queue with a maximum length of 2000, used to store past experiences. This is important for, this is what is storing the past experiences, and due to these experiences it is learning to move perfectly. So the agent samples batches from this memory to train, which improves learning stability by reusing past experiences and breaking the temporal correlation in the data. These components together provide the basis for DQN agent to learn by storing experiences during the policy network to make decisions, periodically updating the target network to stabilize training. I think it has completed 2000 passes because there is no issue with the program, and I think it has completed the process. That's why it is not moving. Movement and reward function. So what reward is, I already told you. If it moves in a correct path, it will get a reward, positive one, and negative if it is not in the right place or on the obstacle. So this is what the reward is. So there are functions involved with this process. So the helper functions include movement and reward calculation, action selection based on an epsilon greedy policy, and model optimization. So let's see the four things: move up, down, left, right. These are the actions. New position and everything. So I have mentioned everything, each and everything in this article. So let's see. These two functions define the movement and reward for the agent as it navigate the grid environment. So get new position. Let's see where we have these helper functions. So let's see get new position. What this is, I told you this, it can only take 4 actions. So for moving up, for moving down, for moving left, for moving right. So what this new position is doing is position 0, action 0, position 1. What this is, so this calculate the agent's new position by adding the values in the action to the current position coordinates. You understand what you are doing. So when you move through the grid, so it will become 0, 1, 2, 3, 4 like this. So what this new position is doing is incrementing it by 1. This is what it is doing, and what this condition is all about. What this condition is saying is, this condition checks if the new position is within the grid boundaries. So if the new position is within the bounds, the function returns new position. If the out of bounds, so if it tries to go out of the grid, it returns the current position, so the agent doesn't move outside the grid. And you know what grid is, so it should not move outside the grid. So this is the condition it will use to keep the agent inside the grid. Where it is, yeah, here, get new position. Here we have this condition, get reward position. So this function assigns rewards based on the agent's position, guiding its learning by encouraging reaching the goal and avoiding obstacles. So if position equals to goal underscore position, if the agent reaches the goal, it receives a reward of 100. If agent reaches its goal, it receives a reward of 100, a large positive reward indicating a successful episode. If position in obstacle, if the agent lands on obstacle, that's red part, it receives a reward of -100, a large penalty discouraging this action in future moves. So return -1 for all other positions. The agent receives a small negative reward to encourage it to reach the goal quickly, avoiding unnecessary moves. So together these functions manage the agent's movement within the grid and helps it learn effective navigation by assigning rewards based on the action and outcomes. So this is the get rewards function. So you can see the goal position getting 100, and for the obstacles -100, and for -1 a small penalty. Okay, so I have mentioned in code also the comments. I will continue this session in next video. See you in next video. Have a nice day.